In this video, we're going to look at section 1.3. So in this section, we are going to focus solely on estimation. And with estimation, we are going to just start off very simply by reviewing rules of rounding, because there are going to be a lot of times where maybe we have to round. And so we want to make sure we're rounding appropriately. When we are working a problem in mathematics and we have to round, we want to look at whatever digit we're rounding to. So if we're rounding to a specific digit, we have to find the digit directly to the right of that value. And if that number is 5 or bigger, we round up. So if we're rounding to the ones place, or not the ones place, the tenths place, and we're rounding to the tens place, and we have a 2, but behind that 2 is a 5, so then that 5 forces us to round the 2 up to a 3. If that 5 was a 4 or anything smaller, we would keep that 10 as a 2. So if it's 5 or higher, we round up, but if it's below that, we round down. Now, another technique we have when we're dealing with estimation specifically that we can use is using what's called compatible numbers. So this is a slightly different approach, but what this does is it allows us to substitute other numbers that are easier to work with into the problem so that we can still then get an appropriate estimation for the given situation. So we are just going to go through different examples of making sure we've got our estimation skills down, working through these different scenarios, and looking at how we would round appropriately, but also how we would use our compatible numbers in these instances. So the first example we have says, estimate the answer by rounding each number to the nearest 10. So in all of these problems, it's going to be extremely important. I can't stress this enough. Super duper 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 important that we read our directions all the way through so that we're not making any mistakes in our calculations in our process. Okay, because since this is estimation, we're going to want to be very careful about the estimation we're getting. So this says estimate the answer by rounding each number. So that's the first thing. To the nearest 10. That's the second thing. So those two pieces. So we're not rounding after. We're rounding each individual number beforehand. So if we look at this, we have 738. We're rounding to the 10. So this is our 10. The number to the right of that is 8, which is bigger. So we're going to round this to 740. Okay. With the second one, our 10 is the 5. The number behind that is 8, so we're going to round that to 60. With the third one, our 10 is the 5. Behind that is a 0, so we're going to round down to 150. And with the last one, our 10 is the 4. Behind that is a 2. We're going to round down to 40. So now that we have rounded all of these to the nearest 10, we would go ahead and add them together to get our estimation, which is going to be 990. The second example says estimate the answer by using rounding or compatible numbers. All right, we are going to look at focusing specifically for this example on the compatible numbers approach. So we said the compatible numbers, we're just choosing convenient numbers, other numbers that are easier to work with. So if we look at this, we have 19.8 and we have 10.4. We could round to the nearest 10, or not the nearest 10, excuse me. We could round to the ones place. And that would actually give us, in this case, convenient numbers. Because if we look, we've got our ones place. We look at what's behind the decimal. We could round this to 20 and this to 10. Those are also both very convenient numbers. They're very easy to work with. So then when we subtract, we end up with 10. Okay, number 3, estimate the answer by rounding to the nearest integer. So integer, nearest integer means nearest whole number. So looking at this, if we are rounding to the nearest whole number, this is going to be 28. And this will round up to 3. And then we go ahead and we multiply. 28 times 3 gives us 84. Okay, our fourth example says obtain an estimate by rounding the numbers so that the resulting arithmetic can easily be performed by hand or in your head. So again, we are rounding. So what we can do here for this problem, if we want them to be easy, we can round our decimal to the tenths place and round our integer to the 100. So the tens place being right here and then to the 100. So that 0.69, we could round that to 0.7. And then if we round 407 to the nearest 100, that is just 400. So then multiplying those to get our estimate would give us 280. Number 5, estimate the answer by rounding the percent to the nearest 10 and the integer to the nearest 100. So we have our percent, and when we are dealing with percentages like this, with multiplication or anything like that, we always convert the percentage to a decimal. Now, this will be done after our rounding, but we do the conversion for the purposes of multiplying properly. So we are going to round to the nearest 10. So here's the 10, and we're rounding the integer to the nearest 100. So that means this is going to become 10% times 1,400. This is when we would then look at converting that percentage to a decimal. So in doing that, this is going to become 0.10 times 1,400. And then we perform the multiplication to get our final product of 140. Example 6, we start looking at some different word problems because we do always have word problems that we will encounter and stumble upon. Okay, that's the best way that we can relay a lot of information is with a word problem. So example 6, Chandra hires 19 people to pick crops from her field. She agrees to pay them $1.50 for each unit they pick, so $1.50 for each unit. Estimate the total amount of money she will have to pay if each person picks 8 units. So we're estimating here. So we've got 3 moving parts in this problem. We have the number of people, we have the amount, and we have how much each person is picking. So if we want to round this, or we want to estimate this properly, the easiest way to do this is going to be we're going to estimate the number of people. So the 19 people, we can round this to 20. That way it's a compatible number that we can use in our multiplication. She's paying them $1.50. That's a pretty even number already. So we can take our 20 and multiply that by $1.50. And so that would come out to equal $30. So that would be for the group of people, but that's still not taken into consideration. Each person is picking 8 units. So now we're going to take that $30 and expand that. We're going to multiply it by 8 to get our final estimate of $240. Number 7, a box of 7 items costs $14.02. Find the cost of each item using estimation. So this one, we want to pay attention to the wording. Find the cost of each item. I'm underlining that and highlighting that by using estimation. So the box as a whole has 7 items and it's $14.02. We want the cost of each individual item. So we want to know how that grand total is being split up for each of the 7 items. So we are going to need to divide on this one. So that phrasing is extremely important here. But if we're using estimation, we're going to take the $14.02 and round that to a compatible number, round it to the nearest integer. So that's going to give us $14. And then that is a very easy number we can use in our division, knowing that we're splitting it between the 7 items. And then that's just very simple mathematics, very simple arithmetic that we could do to get a final answer. The cost of each would be $2. Now let's look at a few more examples and situations. Okay, so example 8, a $15 tip on a meal that costs $29.47. Use estimation to find the tip. Okay. So with this problem right here, we've got our 15% tip. What we want to do is we are going to use compatible numbers. Why can I not spell compatible? There we go. Compatible numbers. So we could take the 29.47 and round that to 30 to make it that nice compatible number. So we'd make that into 30. So $30 times the 15%. And we did say we want to convert that percentage into a decimal. So it's going to be $30 times 0.15. And so that's going to give us a final answer of $4.50 for our tip. Okay, now we said sometimes we're going to have word problems, and we could also have information presented in a graph or a table of some sort. So we have some examples that are going to look at those different situations. Example 9. Emily is buying plants for spring planting. She bought 3 packs of petunias for $2.81 per pack, 4 packs of Vinkins for $1.31 per flat, and a package of potting soil for $2.89. What is her total bill? Okay. State whether the estimate, okay, so we are still estimating here. State whether the estimate is larger or smaller. So this is a multi-part problem. Got more than one thing we have to do to get full credit. And this piece right here is important. Estimate each of the prices to the nearest 50 cents. So we're going to talk about that. First thing we know, Emily bought 3 packs of petunias for $2.81 per pack. So with our petunias, $2.81 per pack. Now, we do want to estimate the prices, but notice it says estimate to the nearest 50 cents. So if we estimate 281 to the nearest 50 cents, that's going to end up being $3. So we're going to estimate and say that she's paying $3 for each pack of petunias. Okay. So then we would take that and multiply it by 3. So that's going to be $9. Similarly, she has 4 packs of Vincas for $1.31 per flat. So $1.31 per flat. The nearest 50 cents. So this is $1.31. So that is going to be closer to $1.50 than it would be to $1. So we're going to round it to 150. And then we're going to multiply it by 4 because she bought 4 of them. And so then that's going to be a total of $6. And lastly, she has that package of potting soil for $2.89. And when we round that to the nearest 50 cent, that is also going to be closer to $3. So now to find this total for this estimate, we are going to very simply just add these 3 values together. So we've got $9 plus $6 plus $3. And that's going to give us a total of $18. So we found the total bill, but the second half of the question said to state whether the estimate was larger or smaller than the exact answer if we were to actually calculate everything without estimating. And if we think about this for just a second, hopefully we should all realize since we've rounded each of those values up in rounding to the nearest 50 cent, each of those scenarios is an overestimate. So that means the grand total is going to be an overestimate, meaning it'll be larger than the exact answer. Now we did say there are going to be times where maybe we have a chart or a table that we're working with. So we have a couple of examples like that to finish out this section. So example 10 tells us the graph that we see over here on the right shows the gender pay gap in yearly salary between men and women according to education. And there are 2 parts to this question. Part A says, in what category are women farthest from men in salaries? Part B wants to know in what category are women closest to men in salaries. And so we notice we have our different categories, A, B, C, and D in the graph, and they're listed underneath. And then we have our bars for this graph color-coded. The blue is women and the maroon is men. So for part A, just looking at which category are women the farthest? So we're just comparing those bars and looking at what's the biggest gap? Where's the biggest difference? And so it looks like the biggest difference would be in the 2 bars for part B. And if we look down underneath at the key, part B is high school graduates. And then part B of this question is asking, part B is wanting to know which category are women closest to men in salaries, and that is going to be comparing the bars. We notice that is all workers. So then that brings us to our last example here, number 11. So in this example, we are looking at a pie chart, and we're told it's showing revenues for the government in billions of dollars. We want to use the graph to estimate how much revenue is derived from income taxes. Total revenue is $1,797 billion. Total revenue, we're specifically focused on income taxes. So with income taxes right here, that's 44%. And we are going to estimate how much. So using our compatible numbers, we've got the $1,797 billion. And so the most convenient compatible number for that would be 1,800. We've also got our income tax of 44%. That conveniently could be rounded to 40. And then from there we can multiply 1,800 times 40%, which as a decimal is going to be 0.4. And so that would give us a total of $720. Okay. So that concludes our notes for section 1.3.